The last part of this section is really just a recap of asymptotes. So we've been talking a lot about horizontal asymptotes and end behavior, but I want you to also realize that there are also vertical asymptotes. So you will have questions that will ask you to find all asymptotes. So let's recap how you find a vertical asymptote. So a vertical asymptote are always going to be the ones that make the denominator equal to 0. So it's basically where it's making it undefined. We call it a non-removable discontinuity. Vertical asymptotes are always written in the form x equals because it is written as a vertical line, x equals. They are created by limits that we actually get an infinite value as I approach a certain finite number. So for example, it could be something like as I approach 5 of my function, I'm getting an infinite value because as I get close to it, I have this asymptote. As I get close to it, I'm going up towards infinity, That's how it's created with limits. Horizontal asymptotes are always in the form y equals because they are written as horizontal lines, and they are going to be found using those limit guidelines. They are going to be created by limits that either go to positive infinity or negative infinity and give us that finite value, like y equals 2 or y equals 5, something like that. You do have the potential of having more than one vertical asymptote or none at all, and you also have the potential of having one or two horizontal asymptotes or none at all. Horizontal looking at end behavior, vertical looking at basically a gap in the graph where you are approaching a value but never touch it. So if you look at these functions down below, the question is, where are the asymptotes? So for the first one, I'm going to start with horizontal because we've been spending all our time doing horizontal. We're going to use our limit guidelines. So you'll notice that it's the same degree on the top as it is on the bottom. So therefore, my limit as I go to infinity will be 2 over 1, or 2. So that means my horizontal asymptote has the equation y equals 2. Vertical, the focus is on the bottom. What makes the bottom 0? Now, it has to be something that makes the bottom 0, but not the top 0. The one value that makes the bottom 0 is x equals 3. So that will be our vertical line that represents the vertical asymptote. For the second one, horizontal asymptote, looking at the degrees, this time we have a bigger degree on the bottom, which means my limit as I go to infinity is going to be 0, which is going to create a horizontal asymptote at y equals 0. Now my vertical, you can actually factor the bottom. It factors x plus 1, x minus 1. So we have two vertical asymptotes, which happens at plus and at minus 1. And then the third one, horizontal asymptote, same degree on the top and bottom, so we're going to use those leading coefficients. We get y equals 2. Vertical asymptotes, this denominator will never equal 0. So when that happens, we have none, which many functions don't have any vertical asymptotes. They're more the exception rather than the rule. So I want to show you what Delta Math's going to ask in one section, just so you get a chance to practice it. So this was one of the last things that you'll do today, is they'll give you a picture, no function known. We don't know what the name of this function is, but they're going to ask us what are the equations for the vertical and horizontal asymptotes, and basically how does the limit kind of create them. So when I look at my picture, vertical asymptotes, you're going to see this idea of things going close together but not touching. So here at x equals -2, you can see that there's a vertical asymptote. You can see another one here at x equals 6. Again, these two pieces of the graph are getting really close but don't touch. Horizontal asymptotes, you're going to look at the end. Now, on the left end, it looks like it's going down. It's not flattening. So there's no horizontal asymptote on the left side. But if you look at the right side, my right side does have that flattening look. So that would create a horizontal asymptote. So first, my total. So I have 2 vertical and 1 horizontal. So that would be 3 total. As soon as you tell it how many there are, you get a chance to fill in what they are. So let's start with the vertical. So it looks like I have a vertical at -2 and a vertical at 6. So we have a vertical asymptote. It'll automatically switch it to x equals, which is great, at -2. And the reason I do is as I approach -2, I'm getting bigger and bigger and bigger. So as I go on the left side and the right side of -2, my limit is getting really large. So as I approach -2, my function is going towards infinity. I also have the same issue at 6. So at x equals 6, I have a vertical asymptote for the same reason. As I approach 6, my function is getting really big. My horizontal asymptote, as soon as I say horizontal asymptote, it's going to make it y equals. It looks like it's flattening out at y equals -4. So I'm going to type in -4. My reason for my horizontal asymptote is an end behavior. As I go towards, this is the right end, so I'm looking as I go towards positive infinity for x, my function is getting flattened and going to -4. So I'm going to fill that in. There we go. And there you have it. And it will actually draw them for you so you get to see it. So if you need to see a couple more examples, and it will also talk you through again what forms these asymptotes. So it's a nice visual way to confirm all of that. And that is the end of section 3.5.